All right. Anybody watch the Masters over the weekend? I watched hours and hours and hours of golf in the Vision Pro, but man, Tiger. I think I could have competed with him over the weekend. How do you go from being tied ninth to last place? Hey, still fun to watch. The guy who won the event, Scotty Scheffler, he's number one in the world, so it wasn't like a surprise, but he's like a very public Christian figure. Kind of a interesting thing. I like that. It's obviously I don't use any swear words ever, but I've never heard him caught on a hot mic or anything like that. When I mean, he's just so calm and collected when he's hitting these shots that are like worth millions of dollars. And at the same time, his wife was getting ready to go into labor, and he had made a statement saying that if she went into labor, he would just leave because it's his first child, whatever. Man, that's got to be tough. I mean, if it's like day one of the tournament, but let's say you got 4 holes to play, you got a 3-shot lead like he had yesterday, and let's say he got the call that she went into labor right then. What do you do? Like, well, what did the doctor say? How long do you think she's going to? I don't know. He has won the Masters before, so maybe that makes it a little easier, but I can see definitely skipping all the post interviews and stuff like that and heading to, I'm guessing, his private jet over at Augusta, municipal airport 2 blocks away and getting out of Dodge quick. But I don't know. An interesting thing. All right. So last time we were talking about ways of storing information between runs of our application. So persistent storage. Every single time we launch our application right now, it resets to its initial state. All the pellets are back to where they were, regardless of what we collected. Our hit points is restored, blah, blah, blah. But as you've played video games or whatever before, and typically you save games, right? And next time you launch the game, you pick up where you left off. And so we want to talk about what are some ways of accomplishing this. So, last time we mentioned the idea of maybe using files, and I mentioned file IO as something that's kind of lost some of its shine. And in the early days of computer programming, your only way of persisting data between runs of your application was through file IO. Every operating system has system calls built into it specifically for reading and writing from files. It goes back to the days of popping a floppy disk into the computer, even back when they were floppy. When I was a kid, we had I guess pretty young, they had the 5.25-inch floppy disks, but even before that, they had even larger, almost like record size things that they would put into things, and they held like 20 kilobytes, and it was it was the size of a pizza pan or something like that. So now obviously we your little cheap jump drive even has like 16 gigs of RAM on it, or 16 gigs of memory on it, and then you get the expensive ones that go up to 2 or 4 gigabytes now. So storage is less of an issue, and now we have so much stuff with cloud storage that a lot of times we don't have to attach anything. We put it up in the cloud, or we email it to ourselves, or whatever, that kind of stuff. But one way we can persist stuff is through files. And I think I talked about that a little bit last time and showed you an example of a couple of files. We'll go back and look at that here in a second. Because even within a file, we want to start talking about different formats, different ways we can store things in a file. But files in general are considered relatively slow. But if everything is being loaded when you first launch the application, if it takes an extra 15 seconds to launch the application so it can load in all the saved data from files, maybe that's not the end of the world. Things start getting a little bit rougher if we're dealing with multiplayer type games. especially if the some of your data files are, let's say your player's level was located locally in a file. Well, all you have to do is find a way to edit that file, and all of a sudden your player's a lot higher level than it used to be, right? So a lot of these competitive games, they have to move it up into the cloud so you don't have direct access to your data. So these are all things that are kind of just go into the modern file storage. We're not really going to think about the security aspect of it, but we want to think about what's the right tool for the job, right? So using files is going to certainly be the easiest way for us to store data between runs of our application. Part of that has to do with, like I said, file I/O is built into every operating system. So by default, you have access to reading and writing files in every operating system. We had to see how to do that in C#, and I'll go through that code here again and show you the JSON code, which is what we're going to talk about today. But it's built into every operating system. If we wanted to move into something more like a database, databases are software applications that typically, under the hood, they're still going to be operating on files, right? But they're probably going to load a lot of the stuff into your computer's main memory so they can operate more quickly than reading and writing to your hard drive. Most of you are in the computer architecture class 325, and you've probably learned that, the closer memory is to the CPU, the faster it gets, right? Right on the CPU, you have your hardware register, super, super, super fast memory, but it's also not very big. Then you have like your L1, L2, L3 cache still kind of on the processor, but slower than registers. Then you have your system memory, then you have your hard drive, yada, yada, yada. Okay, so it really depends on how fast you need it. Databases will probably keep most of the data. They'll load it from a file when you launch the database, but it'll be inside of computer memory, so it'll be a little quicker. But maybe the secret sauce of databases typically is that there's usually a query language. There's a way for you to store data, usually in a way that doesn't duplicate data very much, because our relational databases, which, when you hear about tools like Oracle, Microsoft SQL Server, MySQL, PostgreSQL, these are common relational SQL-based databases. That idea of relational databases came out during a time when memory was not common. That's why we had the Y2K bug and things like that. So the idea of not duplicating data was kind of an important thing. Now that, cloud storage is more popular, data is duplicated multiple times, where how you access the data typically is more of a regional thing. So when you store stuff in Microsoft's cloud or Google's cloud, whatever, and you go to access it, it's probably using your IP address to contact the data store that's quickest for your program to talk to, because your data has been duplicated 20 times or something like that. So memory isn't as big of a problem now. A lot of those cloud-based data store type situations have kind of an equivalent of SQL, so an equivalent way of querying the data, saying, hey, give me the user ID of the user with this username and this password, and something like that. And then maybe you use that user ID to go and get his current hit points or whatever, or you do with SQL, you can do a join between multiple tables. So SQL queries are almost like a programming tool in and of itself. We wouldn't call it a programming language. We go back to the beginning of 200. We talked about what's the nature of programming languages, and programming languages all have facilities for asking questions, remembering things, and repetition, right? Well, SQL really can't do all of those things, but it can do a good chunk of it, sort of, kind of. The repetition is kind of maybe the part, but now we also have stored procedures in some of our databases, so it gets a little blurry there. But you certainly wouldn't write general purpose programs in SQL. You're writing things that are very specific to querying data. So I had this slide, database rules of thumb. So you might have, if you need to have it not living locally on your computer, might be cloud storage using tools like Google Firebase, Microsoft Azure, Amazon Web Services. And even when you look at these, they have multiple different data store options, ranging from super fast speed with tools for querying it that usually come at a little bit higher cost to kind of a long-term slow storage that still lives in the cloud that you don't necessarily care about performance and things like that. And that might be where you store a lot of images and that kind of stuff. When you think about your modern video games, pieces of software, things like that, when you download a game and then a lot of times you'll download the initial installer and then it has to download another 40 gigs of data, right? What do you think that data is when you're downloading 40, 50, 60 gigabytes of data? What's the nature of that data? How big do you think the computer program part of that is? Even though those programs are probably larger than the programs we're writing here, right? The actual code is not very big, right? It's just a bunch of text. Even when we compile that code, yeah, it's bigger because now it's had to link in all these libraries and stuff like that. But relative to what we think of as size, it's still going to be fairly small. Even a compiled executable is not a large file. So what is most of that 40 or 50 gigabytes of data? What do you think that what's taking up so much space in your video game? Go ahead. Okay, textures, graphics, video cutscenes, things like that. Things that when you consider your video games, some things can live locally, some things have to be kind of in the cloud for multi-user games. But you certainly don't want to have to be in real time downloading 4K graphics from some server somewhere every single time you play the game. You download the 60 gigs of images and stuff like that once, and then your game loads those textures from the local disk, just like we're doing right now with Unity. So it's ready to go when you're playing the game. But the things that might get passed through the cloud, through the server, might be like in a multiplayer game, your player's position, right? So if you play first-person shooters or something like that, you might not be storing a lot of data long-term because where your guy is positioned right now versus where he's positioned in 1 second, if you had stored it right now in 1 second, that whatever you stored is antiquated, right? And storing stuff does take time, so you don't have a lot of time. So really what you're trying to do is you're trying to keep some level of information gathering in the cloud so that all of the connected game clients, so all the different people who are playing, Counter-Strike or whatever, Call of Duty, their game client that's running on their computer can grab from the cloud the location of their team members and the enemy and those things so they can make sure that they're updating the high resolution graphics on the screen to show where the guy currently is, that kind of stuff. So we kind of do a both and thing. And like we just mentioned, when we're dealing with persistent stats like player level, money, things like that, stuff that as your player earns things, and we want that stuff to be able to be reloaded when you launch the game. That stuff is likely going to be stored in the cloud for a multi-user game because it would allow you to cheat if it was located locally. And some of you have probably seen that with some smartphone apps and things like that, which do for purposes of battery life, do keep a lot of the data local on the device so that your game isn't constantly hitting the network over and over again, unless just the nature of the game demands that. Otherwise, because every single time you are using your Wi-Fi radio or your cellular radio, that's taking a little bit of battery life, right? So you gotta, again, use the right tool for the job. All right. So we have this thing called JSON. And before JSON, let me actually add something in here. How many of you have heard of something called XML? Okay. Where have you seen XML? Any examples of XML being used in something that that you see. The punchline here is JSON's mostly taking it over, but XML is still used today. So XML stands for Extensible Markup Language. So really, this guy is a tool for creating tag-based languages. And we can say this was inspired by HTML. So HTML actually existed before XML existed. So when you look at an HTML document, you might see something like, the first tag is HTML, somewhere near the bottom is /HTML. This is the opening tag. This is the closing tag. Inside of here, maybe you have something called head, and you have title, my page /title /head, something along those lines. So you kind of contain your data inside of something like that. So what I just showed you there technically is HTML, but that's what a tag-based language looks like. It's a language that has opening and closing tags, and typically you store your data in the middle between tags. They also have the ability to store things inside of attributes, where those of you who've done web programming stuff maybe see that with style sheets and stuff where you have attributes you put in there. But this is what XML kind of looks like. So before we, actually, it's not before JSON existed, because JSON already existed, but before JSON was regularly used for storing textual data, XML was kind of the tool we used for that. And you do actually still, you see it through naming conventions. So if you save a Microsoft Word document today, what's the extension? .docx. Typically, when something has an extension that has an X in it like that, it was probably an XML-based file. So before that, older Microsoft Word documents would be .doc files. And that was a proprietary format. So if you were to open up a .doc file inside of the right kind of text editor, because they do still store them as a binary file, but if you were able to read it in plain text, let's say, a .doc file is a proprietary format, that keeps track of information like, font size and bolding and indentation and also, all the extra special things that make a word processor over just Notepad. All right, so it's keeping track of rich formatted data. So you could manipulate the .doc file by hand if you had the ability to read it directly, but it was in a proprietary format. The same thing's true today with PDFs. That's why we have applications that you usually have to pay for if you want to edit PDFs, because PDF itself is a proprietary-ish format. The very least, it's not a plain text format. So you can go into a PDF and you'd have to effectively manipulate the PDF language in order to modify a PDF or get stuff out of it in plain text, yada, yada, yada. All right, so if you were to look at a .docx file today, and you were able to open it in its non-binary format, you would end up with a bunch of XML code, things that kind of looked like this, right? It wouldn't have the same tags that exist inside of HTML, but it would have similar tags that make sense in like a formatted document. All right, so it would have like a bold thing or a header thing, or whatever, things that are related to the document itself. And there's lots of other examples. If you have written an Android application or an iPhone application, although this kind of breaks what I said about the .x being in the extension, files for the user interfaces for iPhone are in a .yaml file, YAML, and that is a XML-based document. And then for Android, it's actually an XML-based document that keeps track of the information that's in your that's on your user interface. So if you're going to have a button somewhere, it'll be opening button tag, the text that's in the button, closing button tag, so on and so forth for all your layout and things like that. So for a long time, XML was kind of the go-to tool for what we would say is formatted data transferred over the internet, something like that. All right, so when we came into these things called APIs, anybody know what an API is? I'm assuming all of you have heard of APIs. Can you tell me anything about an API? Good. Yeah, usually you could almost think about it like our kind of database type thing. And it's not just extraction, but that's probably one of the major pieces of it. So, um, application programming interface, sometimes it's called an abstract programming interface, is what it stands for. Typically, this is call it web/internet. This is not necessarily, when we say web, we're probably talking about a web browser, but really it's something that's in the cloud, something that's out there. Tool that allows us to ask for information or store information. So for example, there's like an API out there for, well, there's a zillion different APIs, but one of the free APIs that's easy to work with is an API that deals with Pokemon, right? So you can ask for a list of all the different Pokemon, and then you can get, you can ask for details about a specific one. And, the early days of that API, it would give you the result in XML. And you would even ask for things sometimes in XML if you were having to give specific information, like give me the information about the Pokemon with this name, something like that. All right, so then we have these things called RESTful APIs. We heard of RESTful APIs before, or just REST APIs? What's special about REST APIs or RESTful APIs? Other than probably extra zero on your paycheck or something like that if you work with them. We have a lot of things like that in tech that just sounds smart, sounds difficult. The irony with RESTful APIs, I'm going to add something here. I'm going to say early APIs were proprietary. Then we had some standards-ish, like something called SOAP. SOAP was one of our API standards. Now we have something called RESTful APIs. Or just REST APIs. You can decide which of those you like better. Now, what's funny is these are our newest, latest, greatest. They've been around for a while now, but newest, latest, greatest API types. And RESTful APIs are actually based on a technology that's existed since the beginning of the internet. Anybody know what that technology is? So like I mentioned with SOAP, they had the kind of a somewhat standardized way of talking to APIs so that you could write a program that communicated with SOAP APIs, and then you could talk to 5 or 6 different SOAP APIs with that one program, maybe with just minor little tweaks. Where RESTful APIs, you have a mechanism for talking to any API that is a RESTful API. You don't change your programming, you just change what you're asking for or which endpoints you're calling for. All right. But RESTful APIs are based on something called HTTP. Where have you seen HTTP before?
Start with the URL.
Yeah, when you're on your web browser, you look up at the upper left where the URL is. It's usually either HTTP or HTTPS for secure. So HTTP is Hypertext Transport Protocol. Okay, and what does that really mean? This is a mechanism for requesting web pages. So we'll say at least initially. HTTP supports 4 functions. We have the get function. We have the post function. Now, for those of you who have done any sort of web programming stuff before, and you created like a web form, like put in your username, password, and hit submit, web forms have an action, and usually they also have a method, and the method is typically either get or post. So anybody who's done web programming before, what's the difference between get and post from your perspective as a web programmer? Nothing. So if you have a web form on a web page that uses the get method, and you're asking for a username and password and hit submit, and the action is the program it's going to call, probably up in the cloud on the web server. What you'll see is up in the URL, you'll see their username and their password. It passes that information, the stuff from your web form, through the URL. Let's call it not very secure. When the person standing behind you can see it, right? Now that doesn't necessarily mean it's bad. It just means that you probably only want to use that stuff for like non-secure, like don't put credit card numbers up there, don't put passwords up there. Usernames might be fine, but you get the point. Host actually sends it as part of the request. So it's still not necessarily encrypted. So if you've taken one of the cybersecurity classes, or if you take one of those, you'll talk about like packet sniffers and things like that. That allows you to sit on the same network as someone, and all of our modern computer networks are based on something called TCP/IP. Which is a packet-based data transport. So if you have a 1 gigabyte file, it breaks it into a whole bunch of tiny little packets and sends it at, let's call it 32 bits at a time, or something along the lines, depending on the standard you're working with. Well, you can, listen on the network, because modern networks, I mean, Wi-Fi is Ethernet, just wireless Ethernet. And Ethernet is a broadcast-based technology, not a serial-based technology. So basically, all the data that's going out there is just on one big pipe, and anybody can reach out and read what's on there and then decide if it's for them or not. When stuff is encrypted, it's not a big deal, because you're pulling down an encrypted packet unless you have the ability to decrypt it. If it's using weak security or something like that, you're just going to be looking at gibberish. But if we were dealing with an unencrypted post from a web form, you could pull down the packets and still get their username and password and all that stuff. It's just not obvious in the URL. It's still there if you want it. So this really isn't that much better. But there are actually 2 more methods that are supported by HTTP. Anybody know what those are? Put and delete. All right. So the idea with RESTful APIs, and this kind of gets back to my original question of, what are APIs for? And she had mentioned that, okay, it's for getting data, and that is true. And that's maybe even the primary use of APIs. I would say 90% of the time when you're using an API, you're asking for information. It might be the current weather information or something like that, but nothing prevents you from interacting with that API for storing data in the cloud or things like that, sending it requests. So the idea behind a RESTful API is that The concept is whenever we have a web service, whenever we have an API that is providing various endpoints for us for requesting data, storing information, updating data, whatever, you can break it down into 4 different methods, 4 different things you might want to do. So get says, give me some data. So it might be give me some data. And we usually call these guys endpoints. So for instance, if you go to, I don't remember what the API is, but it might be, Pokemon.com/list. So the list endpoint might just spit back out all of the Pokemon that it stores. So you have a single, today it's probably a JSON document with all the Pokemon and their information in there. Okay. But maybe you would say, you might have the ability to say, give me a list of all the Pokemon that starts with the letter A. Something like that. So you can give it some additional information, and you would probably send that additional information as like a JSON document. So you would say, still call Pokemon.com/list, but as part of your request, you would say, where name starts with A or something like that. You'd have a way of asking for certain things. All right. So get is typically for giving me some data. Post is store new data. So in that case, this is going to require, we're going to say JSON data to store. You got to tell it what you want to store. So you can, maybe call Pokemon.com/add, and then you get to add your own, you give it the information about your Pokemon, the name, a description, let's just say it's just that. And you give it to it in a JSON type format. Before JSON, it was XML. All right, we'll talk about that a little bit more in here in a second. Okay, put is update existing information. Guess what delete does? Delete existing information. Now, you might have 20 different endpoints that all operate off the get request. Maybe one of them lists all the Pokemon. Maybe another one, I don't know, lists something else. There could be 100 different types of data they're giving you, and you just call the right endpoint to give you the data you're requesting. For a weather API, you might say /current, and that gets you the current weather. You might ask for /5-day forecast, and it gives you a JSON document with the weather for the next 5 days. You might have a /hourly endpoint. All those are gets. You're just saying, give me some data, and it gives you the data relative to the endpoint that you called. Make some sense? And all those things are just web URLs using the GET request, which is a standard. That's what, when you click a link on a web page, the default type of request is a GET request. All right. When you hit a web form on a web page, chances are modernly it's probably a post. I don't see a whole lot of websites anymore that put stuff in the URL. Sometimes what you will see is some things that have been around for a long time. You'll get like that big, long, unique kind of, code value up there. That's kind of key. What that is it's a session key. So it's keeping track of your login sessions so that it knows who you are as you go from page to page to page. And it just generated that session and passing that through the URL. Depending on how they're doing it, that could be a little bit dangerous. Some sites use something more locally called cookies, right? So cookies are something that are stored locally on your computer. They're not up in the cloud. So you have all sorts of different ways, but all those things are effectively the singleton design pattern. How do I keep track of data across multiple pages, just like we're keeping track of data across multiple scenes? Make some sense? So notice here how we have a lot of repeat problem solving across all sorts of different technologies in computer science. Well, it's true for everything, but so this put and delete, they're interesting because until RESTful APIs, these were very, very, very rarely used. since the early days of the internet. And that's kind of what makes it extra funny, because HTML actually was not really built. HTML, hypertext markup language, is what it stands for. It was originally built by some of the early research institutions that made the internet. So this was University of Illinois, Urbana-Champaign, University of Wisconsin, I think Notre Dame, 4 or 5 other ones, but regardless, University of Illinois was one of the original guys. That's where the NCSA, National Center for Supercomputing Applications, is. So they effectively, let's say, invented the internet, something along those lines. I'm sure there was lots of people before them that came up with ideas that they just kind of put together, but they would use all of these different methods in a similar way to what I'm talking about here with RESTful APIs. But then what ended up happening is HTTP got applied to basically web browser stuff. So for years, we basically only used get and posts from there, and then as the internet became a thing, and then as network aware applications became a thing, we started looking at, well, how can we have web services that allow us to get data, update data, whatever, have things in the cloud. And they started with some proprietary type things where you'd have to write new code for every different API you wanted to talk to speak in their specific language. Then they tried to create a standard with SOAP, and finally they went back old school to RESTful APIs, except it has this name that makes it sound new and difficult and smart and whatever, even though it's using something from the very, very beginning of the internet, using a protocol, HTTP. Protocols are the synonym for protocol is language. So it's using a language for transporting hypertext, where hypertext is a tag-based language. That's what HTTP was originally created for. Transport text. All right. So what's interesting about that is it fair to say that HTTP has been time tested? Been used for a while. Probably all the bugs are worked out at this point. I think HTTP probably came out when I was, well, probably it existed before that, but my first recollection of HTTP was probably when I was like 7. So a couple minutes ago is when the thing first came out. So this thing's been time tested. So what I'm telling you is every single modern API you might talk to today, including calls to our most recent, newest, greatest cloud computing, which are effectively APIs with a nice costume on, right? Microsoft Azure is a very rich tool set of API calls. There's lots and lots of endpoints, whether you want to talk to their data storage, whether you want to talk to one of their machine learning APIs, whether you want to talk to, one of their other things. So you could really call these cloud computing services just a large collection of API endpoints. They're based on the same stuff. So if you want to talk to Amazon Web Services, you will use a RESTful API to do it, talk to its endpoints. You'll have an authorization key you have to send, but that's using some standards. There's a standard called like OAuth that allows you to authenticate with an API when it's not just a public call, just saying, give me the free data you have. Because you probably don't want people being able to write to your database without your authentication token. It's kind of just for you is the idea. But RESTful APIs are kind of the modern thing. But the point is when in the early days of APIs being commonly used, the language that we would use for making requests was XML, and the way it would give us our data was XML. So if we assume So let's just assume for our game that we actually have a website. So let's say www.cuwcs.com/user info. slash Mike. Let's say that's the endpoint. All right. So I passed it one piece of information, Mike, for my username. Let's say that my character is stored in our online database somewhere under Mike. This, instead of passing it XML, because what you would do if you didn't do that is you'd call user info, and then as part of the request, you would say username Mike, username, something like that. And then it might give you the results back as, this is going old school. Maybe it gives you something in the format of like a player. Username Mike. HP 15. Pellets 21. Something like that. All right. So I would request the user info for a person with username Mike, and it would give me back this XML. All right. So again, that's our XML. Now our JSON version of this. Okay. First of all, you already noticed that with the opening, closing curly braces, it already feels more like a programming language, right? All right. And we would have things like username, Mike, HP 15, pellets 21. So this is the XML version of the same JSON data. So what would you say is the biggest weakness of XML there? Go ahead.
Just takes up space.
Kind of a lot of fluff in there, right? You really have 3 pieces of data and it's surrounded by kind of a lot of extra characters to describe that data. Now, if you go down to JSON, you still have to have some description stuff, but it is more compact, right? And for those of you, I think I'd mentioned this before, for those of you who have learned Python before, which I think there's several people in here, this looks like a Python dictionary. This also looks like a object in JavaScript is what this guy looks like. All right, so we would say that JSON has kind of become the modern way that we send and receive formatted data, or not, formatted is not the correct word, organized data. All right. Another thing that we can say here about XML is XML does not support collections. Really, I'm talking about arrays. So if I wanted to have 5 players, it would be an opening, closing player tag with all the stuff in the middle, another opening, closing player tag with all the stuff in the middle, another one open with all the stuff in the middle. And then we would have to just keep reading from the document until we ran out of lines. Whereas JSON supports multiple, supports collections of things. So with JSON, I can create a collection a little bit more. I'll just put my closing square break in there after that guy. Because technically it's on the next. Oh, it fits. Okay, there we go. All right, so this is just 2 players in here, but with And actually what we would say here is this is called players, colon, and then you would, oh, I'm sorry. Players, colon, then you'd have your collection of players, and finally you'd have the end of your JSON thing, and all this should be indented 1 if you want to look pretty, I guess. All right, so something along the lines of that. So when you see opening, closing square brackets, that kind of looks like a coding array to you. So given that it's probably going to be computer programmers that are wielding XML or JSON, having a language that's already very familiar to all your C-based languages, pretty handy. So, but this is by no means a new thing. It just happens to have become the popular thing. JSON's been around for a long time. All right, so this is a mechanism for sending, for describing your data. So we kind of have name value pairs, very much like if you're a Python developer, very much like having dictionaries. If you are a C++ developer, we definitely looked at this in C++. These are kind of like structs, right, with name value pairs. Java doesn't support structs. It has you do that through objects without functions. C# brings structs back. Doesn't matter. They all solve the same kind of problem. These are just little power tools for solving this kind of problem of storing multiple pieces of data. All right. So if I go into our project here, I know last time, so I have a this file is what I showed you last time, where this is just a comma separated value. So this would have preceded the idea of XML and JSON, right? So this is like, hey, this is my code. I'm the only one who's going to be looking at the thing. I'll just put my items 1 per line and I'll separate the pieces by commas, and I'm agreeing not to put a comma as part of my information, right? Because I'm using that guy as a separator. Not the end of the world, right? We use comma separated values for spreadsheets all the time still. So it's not like this is bad. You just have some limitations. And you also, when you look at this, even though with this kind of data, we probably could figure out what each thing means, right? You know, this isn't a hard thing, but if we had 50 different values separated by commas and some of them were just weird stuff, we might not know what each one meant. Okay, so this data doesn't have metadata associated with it. We haven't described the data. All right, but this works just fine. And I think we looked at the code that parses this last time, did we not? I think so. Did we walk through the code for this? Yeah. All right, so nothing wrong with this. Read in 1 line at a time, do what you're going to do with that line, and you can break it out into, I think we had an item object, and we just filled in the fields with the constructor, and life went on. As opposed to, here's our JSON version of that guy. All right, so notice here I have the collection of items. So a JSON object is always stored inside of opening, closing curly braces. It's a bunch of name value pairs. In this case, I have a name called items, and its value is a collection of JSON objects, which could be more arrays if you wanted to have more arrays in there. But in this case, I have 2 items. Name, stat impacted modifier, name, stat impacted modifier. So we would read through this guy in JSON and pull it into our code. Now, this data here, we might look at it and say, well, if this is the only data we were going to pass around, is this actually better than this for this simple problem? Maybe not, right? I mean, this is certainly less text. And as long as we stick to our rules, this isn't that big of a deal. And once we go through the code, we'll see that actually working with JSON is, I'll call it a little bit difficult. Depends on the language you're working with as to whether or not JSON is like super convenient or not. For Python, JSON is really easy, really convenient. For languages like Java and C#, Once you understand the way they accomplish it through something called serialization, then you see it's not really difficult, but it does require some additional infrastructure to kind of make it work, as opposed to Python. It just, because it's just like a dictionary, they just turn it into a dictionary and you can instantly use it the way you want to use it, is the idea. All right, so what I'm going to do here is I'm going to make a note. Look at C# JSON code. All right. So if you wanted to start thinking about different items for your game or whatever, I would encourage you to start maybe creating a document that looks like this, following JSON format to get used to using this, because this skill, I promise you, you're going to use in your career, because any company you're going to go and work for, you're going to be talking to APIs, and all those APIs are going to be using JSON. So getting comfortable with this is your bread and butter. This will be your daily job. It's working with JSON documents and pulling data out of it or putting data into it. All right, so we'll start with that next time. You will have an assignment on Wednesday to incorporate this stuff into your code, but let me go through the code at the beginning of class on Wednesday for how to process JSON, because it is a little convoluted. So no homework for Wednesday, and I will see everybody then.